All right, so I think I'm recording, and we're looking at the semester review problems. We're looking here at rational functions, and with rational functions, we've got a lot of characteristics of the graph that we want to go through. So the first thing I would do is to factor the function, both the numerator and denominator. Now I wouldn't cancel things yet, but I would write it in factored form. So in the numerator, this guy factors to what? X minus 6, x plus 2, and the denominator here I can factor out a 3, and then I get x squared minus 4, which factors to x plus 2 times x minus 2. Okay, so I'm going to be able to get a lot of information now from this. It wants me to find the equations of the vertical asymptote. So now it doesn't ask me for the domain, but the domain is all real numbers except negative 2 and positive 2 because they cause division by 0. And if you throw something out of the domain in the graph, it's either going to appear as a vertical asymptote or a hole if it's a rational function. So these factors that cancel, this x plus 2, where x is equal to negative 2, is going to generate a hole in the graph, and we're going to get to that in just a second. But what remains in the denominator after I've reduced it to lowest terms, any variable in the denominator is going to create vertical asymptotes. So this x minus 2, the vertical asymptote, and you must write asymptotes as equations. You just can't write down that the asymptote is 2. You have to write it down that it's x equals 2. And now I don't force you to write the word line there. I write the word line there just to emphasize to you that this represents infinitely many points and not just the single value like an x-intercept or y-intercept, like a coordinate of a point. This is representing infinitely many points. So we've got the vertical asymptote here. Now, for the horizontal asymptotes, we compare the degree of the numerator against the degree of the denominator. And actually, I'm going to go back to where before we factored it, and it's easy for me to see that the degree, I can see it here as well, but the degree of the numerator is 2, and the degree of the denominator is 2. And when I have the degrees that are equal, the horizontal asymptote is a ratio of the leading coefficients. So my horizontal asymptote, that's also a line, and I need to write an equation for it, not just a number. Now, vertical lines are x equals, and horizontal lines are y equals, and the ratio is just 1 divided by 3, so it's the line y equals 1/3. So now we've done the horizontal asymptote. Now, for the x and y intercepts, we let the opposite variable be 0. So to find the x-intercepts, we let y equal 0. So if we let y equal 0, then this function notation is the y. We have to be a little bit careful. If a fraction reduces to 0, it's definitely because of the numerator, not because of the denominator. But I want to be careful. I don't want to call x equals negative 2 an x-intercept because I know because these factors canceled that it's going to create a hole in the graph. So really I look to the reduced fraction and I say that the x-intercept, the graph crosses the x-axis at x equals 6. Now for the y-intercept, I want to plug in x equals 0 into the original function here. Okay, so yeah, I've got this bad cold and I don't want to cough into the microphone. I'm trying to find the y-intercept. I let x equal 0. I want to make sure that I do it before I reduce because I don't want to. If I do it after I've reduced the function, then I may end up saying there is a y-intercept when really that maybe there's a hole on the y-axis. So if I plug in 0 for x, let's come down here and do that. If I plug in 0 for x, let's do it in the reduced step here. These two terms are 0. This is 0, and I have negative 12 divided by negative 12, and this guy is 1, so I don't have a problem with it and stuff. You have to be careful that if there were x is in the denominator. If this was another x, it'd be undefined. So you can't divide by 0. So anyway, you've got to be careful when you're doing these x and y intercepts that you don't call a whole an intercept. That's my whole point. So we found the x-intercept, we found the y-intercept. The last thing to do is to find the whole, because this graph does have a hole in it. So the hole has coordinates x and y. I know the x coordinate. Well, what canceled, x plus 2, that gives me a 0 here at x equals -2. And so since I didn't call -2 an x-intercept, hey, I'm fine. I plug in -2 into the reduced function, so I've got -2 minus 6 over 3 times -2 minus 2. I've got -8. I've got a -12. The negatives cancel. 4 goes into both of those. So if I haven't made an arithmetic error, I'm getting 2/3. Now remember that it's okay for me to plug in -2, because I'm not saying that this point is on the graph of f. I'm saying the exact opposite. I'm saying that I know that the graph does not pass through that point. It comes right up to it, doesn't touch it, and jumps right over it. There's a hole in the graph. And most of the time with the graphing functions are just not capable of giving you that much detail, so you don't even see the hole when you look at a graphing calculator unless it's a real new and real modern graphing calculator. So I think we found everything they asked for. I hope that helps. Talk to you later.